Hey guys, so I'm trying out a bunch of new tools, and then for today, the goal I have is basically to fine-tune a RAG pipeline without manually writing a single line of code, or at least writing as little code as possible myself, right? So I want to have the AI write as much as possible, and I want to step up even more, and I want to make sure I don't type as much as possible. So what I'm going to do is I'm going to use of course Cursor Composer here. So Cursor has an autocomplete, but it also has this Composer functionality. And I also have another app called VoiceFlow that just does automatic dictation. So I could say stuff like switch the embedding model to Cohere, right? And I could now type into Composer, and it's going to just kind of make all those changes for me. So the idea here is that I really want to make this basically speech to app kind of workflow work. Let's see how well it actually works. Okay, so let me just reset this over here. All right, and what we're going to do is we're going to work on this project I've just been sort of working on the side, and it's essentially it's a sales tool search project. So as you know, I'm working on a product called Omni, and Omni basically is in the sales tech space. So we do essentially we create AI agents that helps sales rep do research on their customers. But the sales tech space is such a competitive space where we actually have an internal list where we track 687 different sales tech startups or products that people are using, right? So as just an example, right? So I have here's our list of all these different sales tech products that we have, and I've already gone ahead and scraped this entire list and got their basically their product lines and got their features and got the unique selling points and ideal customer profile. So basically already done the processing. So we actually done this using Omni, so using our own product dove in and scraped this entire company, and basically managed to kind of pull out all this different metadata about a company. And I've also gone ahead and embedded these. So we have this embeddings.json here that basically contains base 64 versions of embeddings. What is this here? Okay, I don't need this. So yeah, so this is a base 64 embeddings, right? So it's in this embedding.json file. So this file is like 100, 200 megs. It's honestly not that big. But I embedded every single one of these products, embedded all different features and benefits and description and whatever. And the idea here is that now I could easily, either cluster the embeddings to automatically make market maps, or actually what I want to do here for this session is to just basically build a better embedding search function. So I already built a basic one here. So let's just kind of run it. So if we run my embedding search function, let's say if I want to have a AI tool that just generate leads for me over email, right? So that's a pretty common functionality. So let's say AI tool that generates. Oh, actually, no, I should be speaking this. Let's do AI tools that generate leads for me over email. Wow, that's really impressive. Okay, so and here you can see I get all these different email marketing platforms. I get all these power tools, Autobound, which is kind of like an AI SDR, like a Spark, and it's actually pretty relevant, right? It's actually quite relevant. Now, of course, there's also some stuff in here that's not as relevant. So I get stuff like no-code browser automation is in here. So I get a few results that's not as relevant, and also there are a few other products, AI SDR and Artisan, that should be showing up here, but it's not, right? And I think the reason here is just because sort of your vanilla embedding search. Let's actually take a look at how the search currently works. So I already wrote this. So this is actually just all generated by Composer. Just like a pretty simple embedded search. It's as naive as it gets. And the way that this thing works is when you first run it, it's going to prompt the user for the search query, right? And then it's going to load up my entire embeddings file. So this is just my existing embeddings I have. And then it's going to load up all my results just so it can return a result later, because it's just done some initial loading. Now what it's going to do is going to run this embedding search function, and it's going to first just essentially, what does this function actually do? Whoops. Oh, I think this actually just creates. Okay, so this actually just creates the embedding. This is actually this is from the AI SDK. So it just kind of creates embeddings through the AI SDK, right? So it creates the embedding vector using my existing embedding model that I already have defined under the library. And this is just the standard OpenAI text embedding model. So I'm using text embedding small, and it just embeds the query, right? And then it basically goes through and does a similarity search between embedding and result embedding. I'm just gonna loop through everything, and literally my retrieval function just array.sort, right? So this is actually kind of a ongoing joke for a lot of AI engineers, where how vector databases are overrated, and you could just do array.sort. Well, here we go, and you can kind of see from my earlier example, I searched through 667 embeddings in about 300, low under 400 milliseconds, which is more than enough for most applications. I want to keep this repo as simple as possible. When I deploy it to my server, I don't want to deal with setting up any database at all, whether it's vector or normal database. It doesn't matter, right? I'm not dealing with tens or hundreds of thousands of records here, so I could just do, your standard cosine similarity, myself, and an array.sort, and that's more than good enough. And it's probably faster too, to be honest, because you're going to deal with this whole network traffic between your main application server and the vector search server. And then just for just so I could get some extra examples, I also did a fuzzy search, just basically did a fuzzy search on a query for name, overview, ideal customer profile, just in case if some user just literally type in the name of the application, I could just come out with I could just return that result really quickly, and then and the final result just this hybrid combination of my fuzzy result and my embedding result. So that's pretty much it. I mean, this is honestly like a pretty naive, pretty basic RAG implementation. I don't expect it to perform very well, right? You can kind of see there's a lot of false positives in the result, but it also have a lot of really, it's got, I think probably 50-60% of relevance, so it's already getting pretty good. So now how can we improve this, right? So there's a couple of things we're going to do. So the first thing we're going to do is we're going to pre-process a query, right? So this is like a pretty low-hanging fruit in terms of just improving your RAG performance result. And specifically, I'm going to be using a technique called Hyde, which is basically called hypothetical document embeddings. So what this basically does is, instead of embedding your query and do a similarity comparison between your query and the result, you're going to basically come up with a bunch of fake results, right? You're literally just going to hallucinate a bunch of fake results using another large language model. And the idea here is that your fake result, even though it's fake, right? So it's not going to have any specific facts, but the embedding space, your fake result will actually probably be closer to the real result than your specific query, especially for something like what I do, right? Because because we're trying to find a specific company, and when a user type in a query, what the user is typing is really a need, right? The user isn't typing in a set of features they want; they're just typing in a problem they want to solve. And a lot of times, the way the user describes the problem they want to solve is going to be very, very different than how a company would describe their features. So actually, in the embedding space, it could be very far away. So we do this side technique, and then and basically we just and hopefully we'll come up with some hypothetical documents that will be a lot closer in the embedding space. So let's actually just give this a shot under Composer. Okay, so let's get going here. So let's see. So what I'm going to do is I'm going to open a Composer here. I'm going to say I want to. Let's see. You know what? I got to get in the habit of just typing. So I want to implement. Whoops. I want to implement a technique called Hyde, Hyde, to essentially generate hypothetical documents that you will then embed in order to generate the query embeddings. So instead of embedding the query right away, it's going to embed the hypothetically generated documents. There's an example of this in the URL that I'm going to send. So let's just kind of do in, just say this URL. Okay, so I'm going to include this URL. Okay, let's just see what happens. So it's going to read this website on Hyde. I mean, the website is in Python, so I'm not actually sure how well this is going to work, but let's see what happens here. Well, that's a lot of changes. It changed the LM dot. Because that's dumb. Okay, because the example used GPU 3.5, and so I actually did this GPU 3.5 package. Okay, and then of course it changed search.ts a lot. So let's see what it did here. So generate hypothetical documents. Okay, that's correct. Okay, and 5 hypothetical documents. Yeah, so it generate a hypothetical document and basically embed all of them. I mean, it looks about right. it literally just used the exact prompt that that article showed. Okay, so this looks good, but what I want to do is I actually want to just use the GPT-4 mini model. So use the GPT-4 mini model that's already defined in LLM.ts, and make sure you use the AI SDK. Oh, this is wrong. It's an LLM. GPT-4 mini is misspelled, but whatever. I think it knows what to do here. Okay, so GPT-4 mini, right? And that's not right. So it probably don't know how to use the AI SDK. So let's actually just give it some we should actually generate with the structured data, because this is much better. Read this article on how to generate structured data using the AI SDK. So you actually want to generate these documents in the structured data, and basically just structure it as an array that you're returning, and we just basically want an array of answers. Okay, so let's see. So generate prompt. Let's see what the schema looks like. Where is my schema? Oh, here's the schema. Oh yeah, it's just array of answer. Okay, this is like super good. All right, let's just accept all. Okay, let's kill this for now. Okay, so let's just go through this real quick. We'll do a human check, generate hypothetical documents. Yep, generate n different paragraph length answers. It's actually a really good prompt. And then, of course, it just does the schema with this answer. And then, yeah, and it's going to do the Hyde embeddings. And it's going to, oh, what? It does the average embedding. Wait, what? This is interesting. So it actually does an average of all the Hyde documents. Okay, so that's actually not what we want, right? Because if you want to do Hyde properly, what it should be doing, it should be doing a retrieval on each individual. Wait, actually, you know what? It did the average for this article. Actually, did the average. That's interesting. Okay, you know what? Let's try it out. I did not know this. You learn something new every day. Let me just commit this. Okay, so let's actually just test this out and see how well it works. It's an average of all the embeddings. Let's say AI tool that does email outreach for me. So it's doing Hyde embedding search. And let's see. Outboundly, reply IO, any reach, pitch breezy. Why do I have two reply here? That's actually kind of wrong. That's just bad data on my part. So it's my bad. This is actually really good. Wow. I mean, this is a lot more relevant, right? So it's got all these cold outreach platforms. Still not. I think the problem is just because it's the search space is so large, because there are just so many of these companies that they just don't know which one to rank. There's probably like 100 of these companies that does cold outreach. Let's just do one called let's say AI meeting recorder. I think I have a much smaller list of meeting recorders. Workspace assistant, transform meeting to actionable items. Limitless is in here. TLDV. MeetGeek, Adam.ai, meeting management platform, yeah. Preparation, follow-up, read. Wow. I actually didn't know I had this many meeting recorded, but this is, so, okay, so you can see this is super relevant, right? So this is actually, damn, the average embedding, wow, actually worked really well. I actually did not know the average embedding was a legitimate technique. I thought you're just supposed to do similarity across every single individual Hyde embedding, but they actually did the average here, which is super interesting. So let's actually try this out. So what we should actually do is, because now we have AI coding, we could actually just rapidly experiment with ideas. So let's do something like, instead of getting the average embedding from all the Hyde embeddings, just retrieve for each individual Hyde embedding, and then the result that you return from the embedding search should just be unique by the name of the result. So this way you don't get a bunch of duplicate results. so I just want to make sure I did get commit so that I can always revert, you know. So in all similarities, okay, so it's going to do Hyde embeddings and Hyde finance, going to do that. All right, that looks good to me. And then what we actually want to do as well is when we do the Hyde embedding search, let's actually just print out the answers just so I could debug it. Oh, that's good to me. Okay, the one problem that AI coding still don't solve for you is spacing or is formatting, which I'm kind of nutty about. Okay. Add blank line for readability. Jesus. All right, let's try this again. So let's do, you know what, we're just going to branch. It's a feature, just an individual Hyde embedding. Okay, so we'll just branch just so that like if this doesn't work, it's, you know, we could just get rid of it. And I'll just commit just in case. Okay, well, whatever. I don't need to git push. All right, so let's do search. So let's say meeting, AI meeting, recorder. I'm actually very curious to see how the document works. So it's physical tool, spoken words. Okay, so these are the Hyde document, right? Professional setting, meeting recorder, user can access the meeting. I could probably improve the prompt in this hypothetical document a lot as well, because these are still like very kind of wishy-washy and doesn't talk about a feature, benefits, and ideal customer profile, and I'm sure I could improve this a lot. But I mean, honestly, it's about the same as before. I mean, there's some nuance, like Sonnet seems more accurate. So this is kind of, I guess this is where I talk about a vibe check, because I'm literally just doing a vibe check right now. I mean, ideally, the right way to do this is you're really supposed to have some sort of metric. You're supposed to have some eval data sets, and you know, ideally, I should just have a list of all the meeting recorder already on the pre-prepared, so that I could just test these different techniques and just compare it to the actual eval result. But you know what? Fuck it. We're just, you know, this is a quick demo. I'm just going to do a quick vibe check. You know, we're not really optimizing the margin here. Every change you make is probably going to either double or half the performance. You could easily tell the performance difference pretty easily. My guess is that, I mean, it does feel better, right? Because before it still get this random AI calls type of features, and you know, and this one actually does feel better because every single one of them almost looks like it's a meeting recording or like conversation intelligence, which I think is super cool. So this is definitely a more accurate route. So I think we just, yeah. So let's go this route. So forget the whole average of the embeddings. That's overkill, and you actually do want to just over retrieve. And you know, you want to kind of, the whole point of Hyde is you could approach a query from multiple different angles. And that's actually what we're going to tune here, because we're going to tune it to be even more specific. So we're not just going to say the simple queries. Because we are a vertical specific product, I could say stuff like the user is a potential customer of, you know what, now the user is looking for useful sales products to purchase. Given the question, given the following question from the user, let's actually do the query later. Generate n different paragraph length answers, and make sure the answers contain say, make sure the answer comprehensively. Why am I typing? Yeah. Make sure the answer comprehensively describe the solution, including ideal customer profile, unique benefits, and potential features. And then what we're going to do is, let's do add XML tag question, and then put in the query. That did not work. Actually, let's see. Apparently, I could do a flow command. flow, add the XML tag question, and then put in query. Okay, you know what? Close enough. That's actually pretty good. I mean, in at the end of the day, in grand scheme of things, it's actually pretty good. Okay, so here's our new prompt, which I think is a lot more specific, which means Hyde should be able to give me a lot more relevant hypothetical embedding documents. Oh, I gotta delete this. Okay, you know what? Let's just try. Let's try again. Let's just commit. AI commit is also super cool, and it's just how it iterates super fast. So let's try again with what did I type last time? AI meeting recorder meeting. Wow, it's got otter. Nice, awesome. This seems even more relevant. Sonnet, Read, Axiom, Atom. I mean, Fireflies. I mean, I know most of these. It should have gotten attention. I don't know why attention didn't show up, but I mean, these look super relevant. What a deal. Such project manager. So capture, transcribe, conversation. Yep, that's good hypothetical document. Streamline communication process. Okay, you know what? Let's add one more because these Hyde documents looks good, but they're too similar, right? So they're still too similar. Make sure. Let's type. Make sure the answers are as different as possible. Okay, so they are a little bit too similar, but it's getting better. Let's do meeting recorder again. And let's just kind of check our embedding search here. So recording, professional tool, attend meetings, business executives, review meeting, improve collaboration, search through transcripts. Yep. Okay, sure. Reference past decisions, reduce cognitive load, engage. Yep. Accountability, clear recording. Okay. All right. Cool. Yep. So I get the BP update. Update AI is really good. I feel like that might be a new one. When streamline automate. Is that a new one? I'm not sure why attention isn't coming up. So let's just double check. How does attention? Do I even have? I do have attention. Conversational platform to enhance sales process, real-time coaching, draft follow-up emails, sales conversations. Okay. It talks about it. So attention is. I mean, if we're gonna do meeting recorder, attention is definitely one to return. And I think the problem is that the way they talk about themselves is very, very sales process specific. So we'll just give this one more shot. I think the next step, the next layer might actually solve this problem, but just so that we can really over optimize this, let's just give it one more shot. Unique benefits, just say use cases. Okay, we'll just give this one last shot. Well, I don't see attention here, but I do think the list is getting more and more relevant. You can see the similarity score increasing as well. But let's see. Threshold. the answer should talk about specifically about how the product applies to sales. Just because I'm noticing that the initial documents doesn't contain, it can sort of all over the place. SaaS, yep. Meetings. Is this better or this worse? The similarity increased even more, but it might be worse. Centralized repository, meeting recordings, generate reports based on meetings, sifting through, client collaboration, multi-language, integrated CRM. Yep. So Sonnet, Access, conversational. I mean, it still looks pretty good. Meet Geek, Sales Room. Happy. It does look more sales specific. You know what? I think this is good. Okay, let's commit. I think that's an experiment success. So we're going to push this. Okay, so now we implement a Hyde. Okay, so that's actually the easy one. So we did the Hyde re-ranking, or we did Hyde sort of query expansion. Now to actually fully close the loop, we're going to re-rank all the results, because the best rag actually over retrieve the number of results they need to retrieve, and then they pass that through a re-ranker to actually filter that down to a set of sort of top K results. And that's actually how you just, it's your rag. It's really the same problem, right? You want to kind of give them the top K relevant result, but you do actually want to over retrieve first and then re-rank. So what we're going to do here is we're going to use the Cohere's SDK's reranker. So let's actually go back to cursor here, and they just ask a very naive question. So let's actually let's branch out again. Okay, let's refresh. Add Cohere reranker to re-rank the result from embedding. Actually, it shouldn't rank the result from embedding. It should re-rank the full result. So let's restart. Add Cohere reranker to re-rank the combined result, right? Because we want to just fully re-rank everything, because we want to re-rank the fuzzy results as well. Okay, so let's see. Re-rank. I don't think re-rank is supported by AI SDK, so that makes no sense. It just hallucinated a bunch of. It literally just hallucinated a bunch of stuff. Okay, so clearly we got to give it some more directions. So let's actually go to the Cohere reranker here. Is there a way to make this? This is in Python. That one TypeScript. Okay, so let's do. There's probably you could probably infer. Let's see. Use the. Let's paste this to here. Use the Cohere TypeScript SDK. Pretty sure I already installed Cohere AI. Yep, I did. Oh, I need to do the API key. I'll add that one later. Cohere client. Yep. Re-ranking, re-rank. Re-rank. I don't just want to re-rank the overview. Clients. It's pretty easy, actually. But okay, you see here, I think this is the problem, because it's just literally passing in the name and overview for the re-ranker, but I really want to pass in everything. So what I want to do is serialize every single result for a ranker, not just the name and overview. Stringify, okay, clearly it didn't get it. So, well, I didn't know the shape of the sense. I need to add types. The types are wrong. Look at types.ts to see what the result looks like. Jesus, it has to be a better serializer. I mean, I could just stringify the whole thing. Why do I even need to? Why do I even need to like do this whole breakout? Can you just stringify the result directly? I don't think you need to break it out. Do we need an ID here? Okay, I guess we need to, yeah. So Cohere actually does need an ID. Okay, and yep, that makes sense. So just gonna stringify this whole result at data, which makes sense. We're literally just gonna pass in like a JSON result here to Cohere to re-rank. I think that makes sense. I'm gonna re-rank the top 10 results, which I think makes sense as well. But let's just do, okay, this is good. Let's do the top 20. But what we're actually going to do is when we do the embedding search, instead of returning 20 results, we're going to return, let's say, 100 from embedding search, right? So we're going to return just a huge list from embedding search. It's actually not just 100. It's not that big of a deal. And it's all only text. And we're going to send 100 to Cohere, and it's going to return the top 20. And I think that makes sense. Okay, let me pause this here because I need to get the Cohere API key. Okay, we're back. All right, so Cohere key added. This is actually kind of messy. So actually, you know what? Let's just run this in first to make sure it actually works. There's probably some refactor we could do, but let's just commit and run first. It's AI meeting Cohere. It didn't return anything. Okay, but this is a good list. It even got gone. Okay, so I mean, gone's a pretty important one if you're gonna do freaking AI meeting recorder, and of course attention's over here as well. So it's got all of these really good ones. So why did it not return anything? Oh, yeah. So clearly that that didn't work. I'm just kind of the result didn't return anything. The problem is on line 160. So result.document.id, that ID doesn't exist. Document text, really? That doesn't look right. Result.document.text doesn't sound right. It should still be based on ID. Okay, let's maybe we need a human touch here. What the heck? What is this result? So this is a re-rank result. Return none. Document.id. What is in this document? Oh, it is just document.text. document. So I could do index. Use document.index to retrieve the original result. Remember that result.document could be undefined. Oh my god. What model is this? This is Sonnet. Come on, Sonnet. But you should still use result.document.index. I'm really trying to write as little code as possible. So I'm gonna stick to the original goal. Does not exist. Wait, hang on. It does exist. Turn document. How does this not exist? You know what? Okay. This might need a human touch here. So why does this not exist? Let's see. Oh, it just result.index. This is stupid. Okay, well that's on me too. For giving the wrong information. But also it should actually see the type. It should have saw the type. Sorry, not result.document.index, but just result.index. All right, I think that no, there's no errors. Let's see if that works. So it did return. Okay, it definitely did a lot of re-ranking. You can see. Sonnet, Otter, Bubbles, Beat Geek. I mean, these look pretty good. So what we need to do is it re-ranked it using the original query, right? So original user query. But what we should do is, okay, let's do this again. We're going to restart. Move the Cohere client to just to lm.ts. Okay, I misspelled it, but let's see if it works. Okay, yep, Cohere client. Yep. Okay, so that's done. And what we want to do is rewrite the query used for Cohere client.rerank. We actually want to rewrite it to I'm searching for a sales tool, bracket query. Okay, yeah, that was dumb. Rewrite the query used for rerank. You want to rewrite it so that in front of the query you say something like, I'm searching for a sales tool return the most sales specific result. Search information. Yep. And okay, so let's test this again. TLDV, good meetings, sales assistant, Fathom, Superpower, this random company here, TLDV, sales room is really good. Aircraft is really good too. MeetGeek, Sumi, Octo, Blue Dot, Scheduler, AI scheduling assistant, Sonnet. I'm actually kind of curious why attention.tech isn't coming up. That's the only thing that kind of bothers me a little bit, is that to me is a pretty, wait, did they even come out of the Hyde search results? It might not even have came out Hyde. Oh no, it is. But it actually got pretty low similarity. So for whatever reason, the description just didn't match. It just didn't work for attention. But yeah, but I mean, just overall, this is a great list. So there's probably some more you could tune, because I mean, really, what I should be doing is I should be using whatever description I have for attention, and for I should be coming out with my own list of the ideal result, and actually feeding that back into the model to just help it write the prompts for me. And the model can actually prompt engineer a lot better than I can. I'm doing a pretty poor job at it. I'm sure if you improve the Hyde embedding generation a lot, and then you improve the query filter to the reranker a lot, you could actually probably just double the relevant result, even more. Yeah, but I think this is a cool experiment. I did type a little bit, but I think overall mostly just purely just via voice. It's actually pretty cool. Feels like the future. I just wish that I think that the next step is to just fully integrate voice command into every single app, so you don't even need to press enter. You don't even need to do hotkeys. You could just command your computer and just do it for you. That would be a very cool user flow. All right, thank you guys. See ya.